Last class, we've got firearms and fire effects. This lesson, let's implement bullets and bullet effects. After the gun fires the bullet has a radiation effect during flight. So, we need to make bullet preforms and bullet effects preforms. We make the bullet prefab first. In the project panel, select Assets. Then in the text box above, input bullet. You can find relevant materials. The bullet preform here. It is the material format imported into FBX format before us. Already generated. Drag bullet prefab into the scene. Open the prefab. Modify the node name to rifle bullet. Modify the bullet to rotate 90 degrees around the x-axis. Points the bullet in front of the player. Search rigid body. Adding rigid body components to bullet nodes. Because we use radiographic inspection. So, remove the use of rigid body gravity. Prevent bullets from being affected by gravity during flight. The trajectory becomes a parabola. Check all checkboxes that freeze rotation. Prevent bullets during flight or rotation after collision. Afterwards, we need a custom script to control the bullets. Under the Script Weapons folder, create script file rifle bullet. Double-click to open. In the editor interface, Put the custom script just now. Mount on the rifle bullet node. We need to consider what factors are relevant to bullets. For example, in the game, you need to configure the flight speed of the bullet, bullet range, bullet damage value, and bullet detection enemy level. Here, the reason why. Set the level of bullets. Because there are a lot of objects in the game. Not everything that gets hit by a bullet. We all have to deal with injuries. Set this level. It is to facilitate the subsequent placement of enemies at this level. Then deal with the damage of the bullet hit to the enemy. The above properties allow for configuration adjustments. Therefore, it is set to public. In addition, it is also necessary to consider some that cannot be configured by the user. Modified properties, such as bullet rigid body assembly for collision detection, bullet particle system component for controlling bullet flight effects, bullet flight timer used to calculate the total flight time of bullets. The total flight time of the bullet is actually equal to bullet range divided by bullet speed. Current bullet flight time used to accumulate time segments. When the total flight time of the bullet is reached, destroy bullets. In the onStart method, calculate bullet flight time. Get bullet body components. Let the bullets fly forward. Launch an attack. Here the bullets fly forward. It actually follows the outer axis of the bullet. Because we rotated the bullet before. Its current coordinate system. The green y-axis is forward. That's the original up direction. So we set the velocity of the steel component of the bullet. Multiply the vector in this direction by the bullet velocity. On enable method. Get the rigid body component of the bullet node. Determine if it is empty. If there are rigid body components in the bullet preform, the bullet flies forward. Launch an attack. And do collision detection. At this moment, I'm sure some of you have questions. What is the difference between the start method and the unenable method? Method on start will be executed once when the game starts. The method on enable will be in the game object. Deactivated. Execute during reactivation. When a game object will be deactivated. And each activation requires initialization and other operations. Unenabled works well. For example, objects in an object pool. So here's the catch. How to perform collision detection. At this moment, you need to first understand the relevant aspects of the game engine. Since we are using ray detection in the game, so you need to use the ray class in the engine API. Pay attention to its construction method. Is to create a starting point with origin. A ray in a direction. Then physics. This class is a static class, mainly used to handle collision detection, rigid body motion, physical operations such as ray projection. Pay attention to its static method. Click to enter. This method is used for radiographic inspection. The method emits a virtual ray in the scene. Detect whether the radiation intersects with the object, and store the intersection information with the first object. The return value is recastated or undefined. That is, whether the ray intersects the object. With the help of our engine API, collision detection operations can be simplified. The basic idea of collision detection is shoots a ray forward from the current bullet position. The length of the ray is the speed of the bullet, multiplied by a fixed interval. If the ray collides with the trigger, then determine the colliding object. Is it at the level where the bullet is to be tested? If in, then deal with related injuries. Finally, put the bullet back into the object pool. Here we go. So we start with the basic idea of collision detection. To complete the collision detection method, first step, calculate the expected travel distance for the next frame. Which is bullet velocity times fixed delta time. We fixed delta time. It is to prevent different device sound frequencies from being different, lead to differences in effectiveness. Then, shoot a ray in front of the bullet from the current position. Attention! Because we rotated the bullet coordinate system before. So the front is actually the way up. Second step. Call Engine API for radiographic inspection. Unfamiliar students can open our API. Physics class static method recast. The first parameter indicates setting a limit. The second parameter is the maximum projection distance of the ray. That's what we calculated in the first step. Expected moving distance. The fourth parameter is 1. Indicates that the ray is to collide with the trigger for detection. The third parameter must be paid attention to. Because it uses uncalculated. Here we pass the parameter value yi. Indicates that all layers are subject to collision detection. Because Fu S binary. All positions are 1. That is to say, collision detection is required at all locations. If you need to inspect the first and second layers, then use sign of the integer of binary 011. If you want to detect the first and third layers, then use the integer value of binary 0101. If you want to detect layer 123, Then use qi of the integer of binary 0111. The rest and so on. It's very simple. Count from right to left. Which layer do you want to test? Please fill in this position on which floor. Then get a binary number. Convert this binary number to decimal. The third step. If the result of the previous collision detection, the return value is not undefined, indicates that there was a collision. Then get the object on the bullet shape. If the level of the object on the bullet shape is consistent with the bullet detection level, then collision damage treatment is required. Simulate the killing effect of bullets. And finally, set the bullet's enable property to force. That is, the bullet fails. Equivalent to putting back into the object pool. The object pool can be set later. Manage bullets. Here we go. Need to implement bullet flight business logic. Timing on update method. If the time reaches the flight time of the bullet, recycle bullets into the object pool. That is, set the enable property of the bullet to force. The method is the bullet flight timer. If the bullet flight time runs out, return true. Otherwise, return false. If the current accumulated flight time greater than or equal to the flight time of the bullet, then reset the flight timer to 0. Return to 2 indicates that the bullet has finished flying. Otherwise, then each frame interval is accumulated to flight timer. Return false indicates that the bullet is still in flight. Collision detection on fixed update methods. Just call the previous method. At this moment, there's another problem. On update method and on fixed update method. What's the difference? An update function is called in each frame. Can be used to implement game objects, motion animation, input response, and other logic. However, due to the fact that most game engines, rendering and physical calculations are done separately, so use the update function to control the motion of objects will be affected by frame rate, resulting in inconsistent performance on different devices. OnFix update function is called at a fixed time interval. It is typically used to handle physical computations because within a fixed time interval, the results of physical calculations are predictable. So, using OnFix update can be avoided due to unstable frame rate, the resulting physical movement inconsistencies. In general, if you need to handle physical calculations, you should use OnFix update. Otherwise, you can use OnUpdate. One last thing to notice. When the bullet flight is over, some parameters need to be zeroed out. Bullet rigid body velocity 0. The angular velocity of the rigid body of the bullet returns to 0. The current object's position is zeroed. Particle system stops playing special effects. So, need to add method on disable. Implemented in this method. Then make sure to hang it on the node rifle bullet. After defining the script rifle bullet, drag it. Go to the prefabs folder in the project panel. Make a bullet prefab. Then open the rifle bullet node. During the flight of the bullet, because the speed is too fast, you can't actually see the shape of the bullet at all. All I can see is the shooting star-like line of fire in the sky. So you need to make a bullet effect prefab. Select the rifle bullet node. Ctrl-D. Copy to get new node. Rename the new node to rifle bullet effect. Due to the bullet effect, the specific shape of the bullet cannot be seen. Therefore, the mesh renderer needs to be removed. Add a particle system. Here we go. Let's make special effects of bullets flying at high speed. Because of the effect of the bullet flying at high speed, all of a sudden. So, set the startup speed of the particle system to 0. Change the life cycle to 0.5. Analog space. If you choose local, indicates that the controlling particles are in negatively opposed local space. So move in the negative direction. If you choose WG, represents setting animations in world space. Since our bullets are individual bullets, so here we choose the word, creating particle effects in event horizon space. Usually the speed of the bullet does not change during flight. So, check launch. Set the rate of change over time to 0. Set the distance rate to 20. Range rate indicates emission based on moving distance. Particle. Do not fire when not moving. Because the bullet flies in a straight line. So check the form. Set the form to box. Set zoom 000. Check the life cycle color. Set the color to yellow and white gradual change. Adjust the transparency of the white on the right end to an appropriate value. The color of the simulated bullet trajectory. The trajectory of the bullet resembles a shooting star. Appears of a certain size. And then it brightens up. Brightening can be simulated by particle size. Afterwards, after a quick swipe, it becomes smaller and disappears. So, we check the big and small life cycles. Adjust to this curve. You can also adjust it according to the actual effect. Makes bullet marks disappear faster. At this moment, we need to use materials for shooting special effects. Under the other folder in the pre-class information package. In the shoot effect folder is Let's start with the other folders. Copy to the resources folder in the project. Then set the material of the bullet particle system to And finally, let's test the bullet effect. Select the particle effect node rifle bullet effect. Then drag its axis with the mouse. Move fast. You will find that a yellow line is left behind. After passing the test, rifle bullet effect node. Drag to the prefabs folder in the project panel. Generate bullet effect preforms. Finally, open the node rifle bullet effect. This lesson, we made bullet preforms. Use particle effects to create the flight effect of bullets. Next class, let's work together to realize the function of firearms.